The University of Rhode Island has been competing in the International Roboboat competition since its inception in 2008. This year, our vessel has been completely redesigned. A team of skilled URI students have designed a platform from the ground up to compete in the International Robotics Competition hosted by the AUVSI Foundation. Our team is a diverse demographic of engineers who have devoted themselves towards the creation of the URI ASV. The purpose of the URI Autonomous Surface Vehicle is to operate completely free of human interaction. It is expected to complete a certain set of tasks completely on its own without any help from a human. This year's platform has been completely redesigned from previous years. The boat can be broken up into several components: the hulls, frame, electronics box, sensor arrays, and propulsion systems. The hulls were fabricated both in-house and off-site at Navitec in Hawaii. The main shape of the hulls was achieved through a CNC machine for pristine accuracy. Each hull was then assembled at URI by the students. The two halves, which were CNC'd, were adhered together around a carbon fiber keel, and the foam hulls were then coated in several layers of two-part epoxy to provide strength and help seal out the environment. Multiple layers of Interlux marine primer and paint were applied over the glassed hulls, and this produced two beautiful final products. As a finishing touch, the open tops of the hulls were then capped using two pieces of acrylic in order to completely seal out the environment and finish the hulls. The frame used to assemble the two hulls into one platform was composed of several sections of extruded aluminum slot rail. This allowed the frame to be modular with alterations capable of being made on the fly with only a few hand tools. Extra peripherals and components could also be easily mounted to the platform, and the entire system could be disassembled in a matter of minutes. The electronics box housed all of the computers and electronics for the boat. The box was kept sealed from the environment to prevent anything from getting wet. The inside of the box consisted of 6 lithium-ion batteries, a small, powerful computer, motor controllers, a radio for remote control, a BeagleBone for low-level I/O, and a router for communicating with the shore computer. The main computer was responsible for all mission and vision computations and sent instructions to each other component to drive the boat. Mounted to the frame were a variety of sensors which allowed the boat to fully sense its surroundings. A GPS unit was mounted to the top of the electronics box. This allowed the boat to be constantly aware of its global position. A compass was also attached to the frame for absolute direction. A laser radar, or LiDAR, was mounted to the front of the frame. The LiDAR would send out laser pings at an incredibly fast rate to detect anything in front of the boat. It would then provide the mission computer with the position, speed, and bearing of any object in front of the boat. When paired with the camera above it, the boat was capable of determining whether the object in front of it was a buoy or a duck. 2 hydrophones were mounted to the front of the vessel. A hydrophone is essentially a microphone which is to be used underwater. The 2 phones were used as a sonar system for detecting items and pingers placed underwater. A color sensor was also attached under the hulls. This allowed for the color of any object underneath the boat to be determined. For propulsion, 3 electric trolling motors were mounted to the frame. 2 were mounted to the back of the boat at 45-degree angles. This allowed the boat to steer just by applying different amounts of thrust to each motor. A 3rd motor was also mounted between the hulls in the front of the boat. This allowed for a much more maneuverable boat which could surge, sway, and even strafe from side to side.
I'm Jordan Kirby.
And I'm Matthew Iannucci.
We're both recent graduates of the URI Ocean Engineering Department. We're both the co-captains of the URI ASV team. I'm the head of mechanical.
And I'm the head of the software.
My name is Brenton Wallen. I just graduated in ocean engineering.
I'm Scott Hara. I'm a senior ocean engineering major.
We worked on the acoustic pinger localization task.
Hi, I'm Steve Norris. I'm a graduate student studying computer engineering. I've been on the team for 2 years. Last year, I worked on computer vision, and this year, I'm working on missions.
Hello, I'm Tyler Pickering. I'm a senior in the Ocean Engineering Department, and I am on the mechanical team.
My name is Nicholas Deocentis. I'm a 2014 graduate from the University of Rhode Island with a degree in electrical engineering. I worked on the power system for the ASV team for my capstone project.
The International Roboboat Competition was first held in 2008. During the competition, teams of students race autonomous surface vehicles of their own design through an aquatic obstacle course. This includes marine navigation, channel following, and autonomous docking. The competition provides an opportunity for students to develop skills in system engineering by accomplishing realistic missions with autonomous vehicles in the maritime environment. The Roboboat competition is an important key to keeping young engineers excited about careers in engineering and has been tremendously successful in recruiting students into the high-tech field of marine robotics. This year's competition was composed of 5 tasks. The ASVs were expected to complete each task sequentially without any human interaction. The boats would leave the dock and navigate autonomously through 2 navigational gates. They would then enter a field of randomly placed buoys. Using the various sensors, the boats were expected to navigate through the obstacle course without colliding with a buoy. The boats were then given a docking symbol and were expected to dock with a floating platform which corresponded to that symbol. This was to be accomplished using an onboard camera for identifying the correct dock. The boats would then proceed into a field of buoys containing acoustic pingers. The boats were each given frequencies to locate and using underwater sonar had to position themselves over the proper pinger. For the final task, boats would then return to the main launching area and attempt to locate a light bulb array under the water. Using a color sensor, the boats were to determine the order in which an array of colored lights was flashing, and then wirelessly transmit the order to the judge network. This year, Embry-Riddle Aeronautical University took the competition in first place. The URI vessel suffered several hardware and software problems and unfortunately did not live up to our previous years at the Roboboat competition. But this is not stopping us from getting right back into the preparation for next year's competition. Anyone interested in our team should get in touch to get on board the team for an amazing and enlightening experience in the field of robotics.